agent. So this week we will learn about this, and next Wednesday we will take quiz two. Okay, and the range of quiz two will be uh, uh, after the midterm. Okay, so after the midterm, I'm not sure. I will notice exactly in this Wednesday. Anyways, the range of quiz two will be the one we learned after the midterm. Okay. Okay. And also you have to submit a final presentation video by the end of this May. Okay. And we will proceed the final presentation on 1st of June and 8th of June. Okay. Okay. So this is actually the last topic. Actually, the one we have learned, sorry, actually, the one we have learned, the visual recognition tasks are mostly called as nowadays called as the perception AI. Okay, so which classify the images according to their labels or detecting some bounding boxes or pixel-wise segmentation masks. They are called perception AI nowadays. Okay, and also we slightly also learned about the generative AI, which is the GAN or diffusion algorithms. They are generating the images mostly tasks. Okay, we call that as the generative AI. And also nowadays we are seeing the agentic AI via the LLMs and also the vision language models. Okay, and also the AIs are. I mean, in the future of AI, this is the slide from the Jensen Huang, NVIDIA company, his presentation material, and he's saying that the future of AI will be the physical AI, and also the extension of the VLM, actually the VLA, which is called as VLA, which is the Vision Language Action Models, are one form of the implementation of this physical AI. And uh, I mean, now people are thinking the future of AI will be the physical AI. Okay, so agentic AI we will see today, and this is mostly for generating some text and some multimodal signals from the AI. Okay, but in the dialogue manner, they are interacting with humans and generating some useful outputs for humans. Okay, we call that as the agentic AI, but most the output of the agentic AI, they are bounded to uh, the, I mean, the some signals which is electronic. Okay, so which is not existing in the physical world, but in the physical AI, we are thinking that those outputs are interacting with humans in the physical manner. Okay, so in that sense, we are calling that as the physical AI. Okay, so today, anyways, the theme will be related to this agentic AI. We see recent LLMs and VLMs. Okay, so this is the GPT-1 we have learned previously. This is initial language models. I mean, proposed by the OpenAI, and they are using this transformer architecture and do some pre-training using some unlabeled data. So using some self-provisions inherent in the language, uh, they are predicting the next word using the previous words. Okay, this is some inherent self-supervised self-provisions inherent in the language domain, and they pre-train large language models using these, I mean, inherent signals, and then they supervise and fine-tuning the language models, which is pre-trained to the specific tasks using their ground truth. Okay, this is GPT-1, and this paradigm fine-tuning, making the pre-trained large models and fine-tuning to the specific models will be retained in the later language models. Okay, and BERT is another. They are also doing the self-supervision and using the unlabeled data. And this is the type of that unlabeled training. And then they do fine tuning on the specific task. Okay, this is the BERT, and they are recorded as better language models compared to the GPT-1. Okay, and even surpasses human capability in some tasks. And they are continue scaling up. And GPT-2, GPT-3, they are having, times of parameters compared to the BERT or GPT-1. Okay, and eventually, they are becoming very good at doing the few shot or zero shot learning compared to the GPT-1 or previous versions. And also, they observed that the largest GPT-3 models, they are showing very good performance at few shot and zero shot learning compared to their small scale models. Okay, this is important observation which was performed in 2020. And now we are having GPT-5, okay, but GPT-4 was, also the sensational language models after the GPT-3, okay. And one of the important advance was they are inputting multimodal signals, okay, and they are process image and text and produce text output, okay. They can understand not only text but also the images now, okay. And they are also using both public data set and some private data sets, okay. But the thing is, GPT-4 is not, even in their technical report, they are not reporting exact architectures yet. So they are doing this development in closed manner. Okay? So exact number of parameters are not available, but we are expecting that it has 1 tera parameters. Okay? So a lot more than the GPT-3. Okay? And another important modules they have is the RLHF, which is the reinforcement learning from human feedbacks. Okay, so we will see they are pre-training the largest language models using unlabeled data, but then they fine-tune using the RLHF, which is the getting the human feedbacks, and somehow using this, they are aligning their GPT's output to human preference and preventing some safety issues. Okay, so this fine-tuning step is important for, especially for the Chat GPT. Okay, if Chat GPT produces some output, text output, which violates some safety or say how to say some I mean uh, which violates some law. Okay, that will be problem. So to prevent that kind of thing, that kind of issue, this RLHF has been applied for the fine tuning to align GPT's output to fit to humans' preference. And this is also very, how to say, impressive result. Offered by the GPT-4. Okay, so in the x-axis, you can see some of the tests, taken for the humans. So SAT, this is the university entrance exam, and GRE and also other exams are also graduate level exams. And AP, this is the university level exams. Okay. But GPT-3, their 3.5, their performance is like this. They are already recorded good score for some of the exams, but GPT-4, they are recording better performance compared to the GPT 3.5. Okay. And also GPT-4, by scaling up, they are recording the best. Okay. Compared to the GPT 3.5, their performance is improved a lot. And compared to other state-of-the-art, fine-tuned on the phone on each domain, GPT-4, thanks to their generalization capability, they are recording the best, okay, in most of the benchmarks, okay. And this is also some multilingual benchmarking. So they are not good at English, but also good at other languages like Korean, Japanese, and Turkish, and so on. Okay. And also, this is the evaluation for each subject. Okay. So GPT-4 now is very good at doing this type of language-based tasks. Okay. And also, thanks to the RLHF, the fine-tuning, they are not doing disallowed and sensitive, they are not producing sensitive content, okay? Thanks to their fine-tuning method, okay? And GPT-4, they are greatly increasing the problems, okay? That is another important advance made in the GPT-4. And GPT-4o, this is the another, version of GPT that is producing also the multimodal signals. GPT-4 that is producing only the text output, but GPT-4o that is also generating the multimodal signals. So there has been some trend to type this type of Ghibli style image generation last year. Okay. So this was opened, as far as I remember, last year's May. Okay, so they are also producing the images. Okay, okay, and now we are having GPT-5. Okay, actually, but one of the problems which these GPTs are having is they are closely developed, so we cannot know their exact architectures yet. Okay. We can expect, but we cannot see their code. Okay, so there has been some effort made by Meta AI. Okay, and this Llama was first developed by this Meta AI to how to say use only the publicly available data sets and also to publicize the LLM, their code. Okay, so Meta, they are wanting to open source all of the LLM code and their data sets. Okay, so we call that as opening, a beginning of open LLM era, and it is released by early 2023. And one of the other merit of this llama is that their sizes are very small. Okay, so GPT-3 that is having this number of parameters, GPT-3. Okay, compared to this GPT-3, llama is having very small size, but stronger than GPT-3, even though their size is relatively small. Okay, that's one merit of llama. And there are actually four variants in their architectures. And of course, the larger models are exhibiting better performance. Okay. And their architectures are, how to say, slightly different from previous state-of-the-art closed source language models. So they are applying slightly different normalization method compared to the GPT-3. Okay, they use RMS norm. Okay, introduced by some paper, and also differently to this PALM, they are using slightly different activation function, and also they are applying rotary positional embeddings. They are having some using some rotational coordinate rather than the Euclidean coordinate. Okay, so this is very slight. amendment made for their architectures, but they are using the transformer architecture as the main architecture, but using this slightly tuned method. Okay, and they are using RMW, standard RMW method as the training optimizer, and using the publicly available data sets. Okay, they are only using the publicly available data set. Okay, but I mean, you may remember that GPT-4, they are using both publicly available and some private data sets, but on purpose, this llama is using only the publicly available data set. But I mean, seeing this graph, seeing this table, GPT-3, even though they have large parameters, llama, their parameters are relatively less compared to the GPT-3 and other compared to other existing language models like Palm, Chinchilla. Their parameters are also compact. Okay, but even though these smaller sizes in multiple tasks, they are surpassing the other language models. Okay, so and also thanks to their open sourced, I mean, paradigm, this Llama was one of the sensational LLM architectures. Okay, and that was published in 3 years ago, actually. And after this llama was introduced, right after the llama, in Stanford, they are publicizing this alpaca, and they are slightly tuned the llama, their performance, by supplying some, how to say, some synthetic data sets. So they are actually using their GPT 3.5. Okay, they are called as Text Da Vinci version. They are having 70, 700, 175 billion parameters. Okay, that's the GPT 3.0. Okay, 3.5. Okay, their architectures are quite big. Okay, and they are making 52K 52,000 samples from this GPT 3.5. Okay, and then they fine tune the llama with the smallest llama version using these synthetic data sets. They supervised manner, they are fine tuned the llama 7 billion model using these 52K samples obtained from this GPT 3.5. Okay, and they call that as the alpaca 7 billion models. Okay, but after fine tuning, it takes only 3 hours using this amount of GPU resources. And after fine tuning on this synthetic data set, they observed that their performance is becoming similar to GPT 3.5. Okay, they are training the llama, which is the smallest model, using the synthetic data set produced by GPT 3.5, and thereby obtaining the improved version of llama, whose performance is comparable to the GPT 3.5. But this is a very impressive result, considering that this GPT have almost 100 times, not 100 times, but 10 times, not 10 times, but compared to this 175 billion parameters, Llama is only having 7 billion parameters. Anyways, the model size, their size is very small, but their performance is becoming comparable to these big architectures. So this alpaca is also producing the impressive result. Okay, and that takes only 3 hours to fine tuning the llama. Okay, and another important architecture is Vicuna, And this is also doing the similar things to the how to say to the alpaca. Okay, so they fine-tune the llama 13 billion model. Okay, and produce this Big 30 billion models. Okay, and they are saying that their performance is similar to Bard, which is the Google, their language models, and also the ChatGPT, comparable to, but lag behind the ChatGPT, but it's a lot better than Llama, original Llama, and is comparable to ChatGPT. Okay? And what they did was similar to Alpaca, they are fine-tuning the original llama on the data obtained from ShareGPT, which is the repository for saving data, saving the dialogue data obtained from the GPT-4. Okay. So this is a ShareGPT repository. They are obtaining some dialogue data sets obtained from the GPT and fine-tune the Llama, their original version, and observe that their performance is becoming better than original Llama, but comparable to the ChatGPT and Bard. Okay, this is another important method appeared right after the Llama. Okay. And this is the comparison to Llama, Alpaca, and Vicuna. Okay. And they are using 52K samples, Alpaca, they are using 52K samples obtained from GPT, okay? But Bituna, they are using the shared GPT data, which is pre-collected. So they are not spending any effort for collecting the data set, okay? So here, the training cost for Alpaca is mostly spending for the data set collection because they had to collect this number of samples from the original GPT. But in Bigtuna, they don't have to do that, but simply borrowing the data set from the repository and do training. Okay. Okay. They are not available. These bots, ChatGPT, they are commercial language models and their data set, training code, and everything is not available, publicly available. But Llama is first open sourced language models. Okay, and Alpaca, Vicuna, they are improving that, doing some supervised fine tuning. Okay. Okay. So this is some method appeared right after the Llama. And after that, after a few months later, Llama version 2 have been proposed by the Meta AI. And actually, they are the Llama version 1 was not comparable to the GPT 3.5. Okay, but they are becoming real alternative to the GPTs, which is the commercial language models. Okay, so this is showing the power of the open source language models. Okay, they are providing this type of characteristics and providing this sized language models. Okay, and also they are fine-tuning the Llama version 2 for the chat application as well. Okay. This is some important figure for training method of the Llama version 2. They are doing pre-training first, using large corpus of the text data in the unsupervised, self-supervised manner. They are pre-trained the Llama 2 architectures. And then after that, what they do is they first do supervised fine-tuning. So for some of the sentences, they already have ground truths. They are training, fine-tune their Llama version 2 for using those data sets. And also they do reinforcement learning using human feedbacks as well. So for doing this, they are collecting some human preference data set here. Okay. So they are actually getting some human feedbacks, okay, while doing this RLHF, okay. to how to say bound this llama, their outputs to be safe, aware, and also reduce some issues in their output domain. Okay, so they want to align their low outputs to the human preference. Okay, and for doing that, they fine tune the llama version 2. Okay, and by doing that, we can, I mean, the performance-wise, when compared to the ChatGPT, we can see it is the Llama version 2. Most of the persons are thinking the Llama version 2, their outputs are in good quality compared to the ChatGPT. Okay, and also compared to the previous version of language model PaLM, and when compared to Falcon, Vicuna, and others, Llama version 2, they are becoming prevail compared to the previous language models. Okay, and also when thinking of both helpfulness and the safety, okay, the GPT Llama 2 is becoming better than GPT, PaLM, or Falcon, the previous language models. Okay, and this is also showing the violation. Which violating some safety. Okay, so the lower is better, and Llama 2 is also reducing a lot of concerns on safety. Okay, compared to other language models. Okay, and when compared to the Llama version 1, okay, they are also becoming better than becoming how to say using larger context lengths, and also use this GQA. Okay, I will explain that later, and also uses more tokens. Okay, and they are increasing the capability of the architectures. And this is the GQA, which is proposed by this paper, actually ENMLP. And the core idea is this is the original multi-head attentions. Okay, there are key query values. Okay, one queries we are using dense values and keys. Okay, but after that, because of the efficiency issue, this multi-query method has been proposed, which uses only shared value and key for all of the queries. Okay, but this can greatly reduce the time consumption for calculating the multi-head attention. But the thing is, this will greatly reduce the diversity and thereby limiting the performance in overall transformer architecture. So this GQA is proposed. That is actually the intermediate concept between these multi-query and multi-head attentions. They are using some uh, value and key for, they are grouping the query, okay? And for each groups, they are using some shared key and values. That is the group query attention. So they are observing that this GQA is better in time compared to the multi-head attention, but sometimes similar to MQA. Okay, but their performance is comparable to full MHA. Is better than MQA, which uses only one key and values for all the queries. Okay, so this GQA is uh, having very good trade-off between this MHA and MQA. So they are most of language models are using this GQA. Okay, and this is showing according to the GQA groups. Okay, this is the y-axis is showing the speed of the attention mechanism. MHA that's constant, and MQA because they are having just one km values. So they are also constant, but GQA, according to the number of groups, they are exponentially growing. Okay. But observing using only grouped key values, they are having very good trade-off between performance and speed. So most of the language models are using this grouped query attention. Okay. Anyways, Llama 2, that is also using this GQA. Okay. In their architectures, they are borrowing the idea of GQA and also growing context length and tokens. Okay. That is the technical improvement made for the Llama version 2. And also, thanks to this technical component, Llama version 2, they are becoming better than Llama version 1. Okay. And later, in 2024 and July, GPT-4 level open source language models are appeared, and that is called as Llama version 3. Okay. They are scaling up the data quality and also the size. Okay. And they are also providing the multilingual capability, and also they can code as well. Okay. And they are having this improved tokenizer, longer context support, and higher quality training data, and have very large parameters. Okay. And they are also providing 3 variants for the architectures, and this is some details for these 3 different architectures. And Llama version 3, that is also trained similarly to previous versions. They are first apply the pre-training in the unsupervised, self-supervised manner, okay? And then do this type of fine-tuning, okay? For aligning their outputs to the human preference, they first apply supervised fine-tuning and then apply RLHF, okay? That is the Llama 3. Okay. And also Llama 3, that is having, how to say, the low Llama 3, that is the version which is, I mean, not applied with the fine tuning. Okay. And when doing the fine tuning, we call that as the instruct. Okay. And here you can see the larger versions of Llama 3 that is supporting the multilingual capability and tool use capability. Okay. And they are actually surpassing the GPT 4. This is the 3 different Llama 3 models, their performance. And Llama 3, the largest model, is surpassing the GPT-4 in some of the benchmark. Okay. Okay. Considering their small parameters, GPT-4, their exact architectures is not public, but we are expecting that it has over 1 tera parameters. But considering the small architectures, this Llama 3, even though they have only 405 billion parameters, they are surpassing the GPT-4. Okay. And also, in this exam data set, okay, the university level, graduate level exams, Llama is also surpassing GPT-4. Okay. So now we have Llama 4. Okay. If you are interested in more recent version of Llama, then you can refer their technical report. Okay. And this is another open source language models released by Alibaba, the Chinese company. Okay. And because they are mostly dealing with Chinese, okay, they are initially start for the supporting of multilingual understanding. They are mainly support the English and Chinese. Okay. And also they have coding and agent capability. Their performance, QN is also having multiple versions. They are having, as far as I remember, their recent version is 3, QN 3. They are the first version of QN, they are lag behind. Their performance is lag behind GPT 3 and 4. but showing better performance than other open source models. So they are compare their performance to other open source models, and they argue that their performance is better than other open source models. Okay, and they are having multilingual tokenizer from their initial version and support multilingual languages. Okay. And they also increase the code pre-training and tool use and agent-oriented tunings. Okay, they are having multiple fine-tuning methods that try to fine-tune these QN language models to other tool usage or agent or code machines. So this is showing that QN, their performance is actually lag behind the GPTs. Okay, so GPTs, their performance are around here, but QN, their performance is only like this, but they are better than other open source models. Okay, and they are providing three different variants. Okay, and I mean, similar to others, they are using some multitasks. They are measuring some zero shot performance, and they are arguing that their performance is worse than these GPTs, but better than these other types of open source models. And after that, after 1 year, QM version 2 has been publicized, and they are also using GQA, which is the efficient attention. And they are also try to optimize their inference efficiency. Okay, and also using some synthetic data. Okay, and also they also increase the alignment uh, their performance. Okay, aligned to human preference. Okay, and this is some what to say variant, their architectural variant. But one thing you have to note here is MOE. So the largest QN2 architecture, they are having MOE, okay, which is the abbreviation for mixture of expert. So today my pen is out of battery, so I'm writing that with my hand. Anyways, this is the mixture of expert, okay? So one of the merit of this mixture of expert is they are having some routing, okay? They are explicitly calculate, for example, they first have some routing paths, and in multiple route, they are selecting few route in feed forwarding paths. Okay, so they don't have to go this route. Okay, and by doing that, they can increase the efficiency of the overall architecture during the inference step. So they take only few of route in network feed forwarding paths. Okay, that is the mixture of expert. They call this each path as the expert and interpret the network as the mixture of this expert route and select only few of them. Okay? That is the concept of mixture of expert, and which is the uh, I mean popular method for making the architecture efficient. Okay, and when compare their variant model variant to other method, they are comparing their method to other open source method, okay? And they are saying their performance is better than them, okay? This is QN2, and later QN version 3, as far as I remember, is the most recent one. And after that, this DeepSeek has been publicized, okay? DeepSeek by DeepSeek AI. And they are also having MOE structure to make overall LLM computation very efficient. So they have router, and for multiple route, they select only few of them to make the inference efficient. And even though they have very large parameters, thanks to this MOE structure, this DeepSeek version 3 is becoming efficient. And they are performing better than other Llama or QN, their versions. Okay. And also they are becoming even better than GPT-4, okay, which is the commercial language models. That is the DeepSeek. Okay. And also in South Korea, there are already many LLM models. Secured by some big companies, Naver, LG Upstage, Kakao, KT, NC, and others. Okay, so if you are interested in developing LLM or VLM, you have to go one of these companies, maybe. Yeah. Okay, so this is some summary for LLM researches. Okay, so they are one of the biggest trend in LLM development is they are scaling the model size and also supplying more data. Okay, by doing that, they can make the model that is performing better than previous. Okay, and also they are doing some alignment. Okay, to fit to human preference, okay, to prevent some safety issues. They are aligning their low language models output to the human preference using the RL, okay. And also, I didn't explain this part yet, but when seeing the GPT-4 supports the multimodal signals, and also Quen is supporting the multilingual signals. Okay, so the language models are nowadays becoming to support multimodal signals. Okay, and also eventually supporting the physical AI, okay, by generating some real actions for the robotic signals. So they are becoming better in the sense that they are producing only the text output, but now becoming to generate images or audio, or becoming to generate some physical signals. Okay, and also the LLMs were developed for only closed source manner in big companies, but nowadays, thanks to Meta and Alibaba and others, the LLM search are becoming open source. Okay, and this is good for this type of rapid improvement and faster adaptation and so on. Okay. Okay. So yeah. And so far, we have seen some of the recent trend in the LLMs. Okay, we will see how they extend their architectures to use the vision signals or other multimodal signals. Okay, and one of the pioneered architecture for this type of uh, caption generation for the images, okay, was the blip, okay, which is similar to the clip, but have more dedicated module to generate the captions. Okay, clip is more about aligning the language and image pairs. Okay, but blip is explicitly developed for generating some captions for the images. And they are using web data. Okay, and what they do is, uh, I mean, they are web data. They can have some web captions. Okay, but they are additionally trained these two networks that generate some captions for this web data, and another network that can filter out to remove the noise captions. Okay, and by using these two types of network, the blip is becoming robust than the clip and becoming to achieve the caption generation task. Okay, And this is the earliest form of the vision language models. Uh, and actually, this part, there are three distinct parts in this belief, in this figure. And the first part is quite similar to the clip that we have learned. Okay? So this part is the image encoding part, and this is showing the image encoder. And this is the text encoder part, okay? And using image text contrastive loss, ITC denotes the image text contrastive loss, okay? That is used for the clip, okay? And using this part, this part is same as actually the clip. And they are aligning image and text encoder. And by doing that, they train image encoder and text encoder first. Okay, this is the first part. And then what they do next is uh, they are getting some signals. This is another text encoder. Okay, and for the text signals, they are this vision encoder, image encoders are already trained by aligning their output to these text signals. Okay, and then they are using those text signal aligned vision feature when training this text encoder. So we call this encoder as the image grounded text encoder. Okay. So in the middle of the text encoder, they are cross-attend with the vision encoder output, which is aligned to the unimodal text encoder. Okay. And then they are trained using this image text matching loss. Okay. So this loss is doing some binary classification. When this image input and text inputs are matched, this binary classifier produces one. But if they are not matched, they are learned to produce zero. Okay. And by doing that, they can train image grounded text encoder. Okay. So now their encoders are becoming to understand the image signals as well. And then they train image grounded text decoder. Similarly to the encoder part, they are getting vision signals, okay, vision features, and their decoders are cross-attended, text decoders are cross-attended with the vision signals and trained to generate languages. So LM denote the language model's loss, their original loss functions. Okay, to generate the language signals, they are trained. Okay, so by doing this, uh, I mean, they will use this part for the inference step. Okay, they are using both text and images and text signals. Okay, and using image encoder and image grounded text encoder and image grounded text decoder to get image input and text input and generate some languages. Okay. And by doing that, this method is explicitly can generate image captions, seeing both images themselves and also the text input. Okay, that is the belief. And another important technical component of the belief is also this part. Okay, and they are training the belief architecture. Sorry. Similarly to the language models, they are doing, sorry, they are doing the pre-training. They are doing the pre-training and also fine-tune the models for the, they will fine-tune the models to downstream tasks. Okay. And when doing that, they can use two types of data, which is the web scale IWTW, that is denoting web images, and web text, okay? And IHTH, that is the human annotated images and human annotated text, okay? We think human annotated annotations are better in quality compared to the web annotations, okay? So here, what they do is uh, they are training the filter and captioner. Okay, filter is actually image grounded text encoder. Okay, I mean this part is very important actually. This part is actually called as filter, and this part, decoder part, is called as captioner. Okay, so here why they are called as filter means is they are matching the text and images and doing some cross attention and output either 0 or 1. Okay, when text and images are matched, they are outputting 1. Otherwise, they will output 0. Okay, so by doing that, they are filtering the text descriptions which is not exactly fit to the images. And also, this captioner part, they are generating captions for the images. Okay, so because of that, this part is called as filter, and this part is called as captioner. Okay, so here, image grounded text decoder, that's the captioner, and image grounded encoder, that is the filter. And what they do here is they are apply LM rules, ITC rules. Maybe, yeah, this is almost end. So, I mean, we can continue, maybe, yeah. I mean, uh, we are training filter and captioner using three loss functions that we see here, ITC, ITM, LM. That is the three loss functions applied to this belief, okay? They are applying this and using the hand-labeled data to train this encoder and decoder part, okay? And then for the web scale data, TIWTW, the motivation is that the web scale data, they are assuming that their text annotation could be wrong, okay? So even for the paired data, they are do filtering and then generate the filtered web data, web annotate, filtered web text. Okay, and this is the also the generating some captions for the web data, and then apply with the filtering operation, and then if that synthesized captions from the captioner is better than the original web annotated text, then they will use that as uh, their annotations. Okay, so they are somehow filtering the original web scale and hand labeled data by using this filter and captioner part. They are training and then reorganize the data set which is used for their training. Okay, that is another important technical component in Belief. And this is actually initial VLMs. Okay, and they are exhibiting better performance by involving this bootstrapping. Okay, so this uh, generating some data captions and removing some captions, they are called as bootstrapping, and this is only having captioner and filtering. When they have both captioner and filter, they produce the best accuracy in most of the benchmark. Okay, so they are proving that this captioner filter they are working, and producing better performance when involved during the training. And this is also comparison to the original clip. Thanks to their improved captions, their performance is becoming better than clip. And maybe for the Flamingo and others, we will see some basic, how to say, the VLMs, which is from scratch. The initial VLMs are trained, okay? But later, after the blip, the researchers are actually extending the existing LLMs for these vision language domains. And Lava is also the vision language models that is extended to the vision domain from the Llama, okay? QMVL, that is the extended VLMs from the QM, okay? So we will see what kind of VLMs there are, okay, in the literature. And also, we will also see the physical AI extended version of VLM, okay? So this is the input image, and this is the text instruction. And they are actually generating some robot control signals. And we call this as the vision language action model, which is the VLA models. And we will see what kind of methods are there, okay, in the literatures, okay, in the next class. So today we can finish here, and also let's see this Wednesday. Okay, thanks.